forgotten actually. So
Yeah,
you
yeah, yes,
see,
that's why. Yeah, sir, it's now started. Thank you.
okay, okay,
Yes, sir.
okay,
It
okay,
was
we can
more
start.
stress and that.
Okay, okay,
Yes,
okay, okay. We starting today milling machine. So this whatever you're seeing this in this circle. So this is a typical milling machine. So in this milling machine, you see it is similar to the drilling machine. You may have seen drilling machine as well as your similar to the drilling machine. So in that you having a base. So here also base is there. So previous drilling machine you having a column. So here also column is there. Inside the column there is a mechanism. Similarly for your shaper also the same thing. Last class whatever the machines shaper or drilling machine, all the machines are similar only. Even milling machine also similar to that only. In shaper machine what you have, you used to have a ram, right? So ram is reciprocating. It's in the linear direction. It is reciprocating. Here instead of ram, we used to have an overarm, and this overarm is a fixed at this particular position. It is not reciprocating. So in under this overarm, there is a arbor is there. So this whatever pink color column you're seeing, this is called as a arbor. So arbor is nothing but a tool holder actually. So this used to be the tool holder we used to call as a arbor. So on this arbor, maybe you can see this is whatever the brown color portion. This is actually a milling cutter. So this portion is a milling cutter. The cutter are nothing but because it's using for milling. That's why used to call as a milling cutter. So this is actually a cutting portion. And in this, whatever this portion you can see. So this is your workpiece, and this is the table. So work table. So workpiece is mounted on the work table because workpiece is very smaller. So you can directly mount on the work table, or maybe you can have a vise on this, and on the vise maybe you can keep it your work table. That's similar to whatever your previous machines. The same working principle. There is a table is there, so this table can be moved up and down, and this you can rotate at different speeds. So here, so workpiece is stationary. So as you are seen in the shaper, same principle. Workpiece is stationary and tool is rotating. In shaper, tool is reciprocating. In milling machine, shape is rotate. So your cutting tool, whatever is there, it's rotating about its axis. It's not reciprocating, rotating about its axis. As it rotates, it's removing the material. And so workpiece is moving forward and backward. So workpiece is moving because this is rotating about its axis, and this whatever the workpiece is there moving forward. If workpiece is moving forward, then only your material is removing layer by layer in all the surface of the material. If it is not feed, if it is a feed motion is not given, if it is not move forward, so what happened? So you can machining only at this particular time. So just give me 1 minute. So yes, so this is a typical working principle of milling machine. So milling is a basic machining process. So after lathe, whatever we have seen first machine, so after that machine, most commonly used machine is milling machine for cutting the material. So lathe is most common. So after lathe, most basic machine is milling machine. So in this, what we used to do, we is generating new surfaces, are nothing but removing the material on the surface. So maybe surface, maybe flat surface, or maybe circular surface also. So previous machines, whatever we have seen, in lathe machine, we can do machining only on the circular surface, not on the flat surface. Where is the shaper slaughter planer, we can remove the material only on the flat surface, not on the curved surface. But in milling machine, we can do both. So we can do the flat surface machining as well as the circular surfaces are nothing but curved surfaces also can be possible to machine. So progressively removing the material layer by layer. So normally in every machining process, so material is removing layer by layer, right? So here what happened? So workpiece is cutter is rotating, and workpiece is feed against this rotating cutter. So if you take the definition, milling is a basic machining process by which surface is generated. So surface is generated nothing but above surface, whatever the unwanted material used to cut, and new surface is generated progressively by the removal of chips. And the chips is nothing but unwanted material. So removal of unwanted material in the form of chip from a workpiece as it is fed. The workpiece is fed to a rotating cutter, or nothing but rotating cutter or rotating tool. So these milling machine can be classified. Milling process can be classified into two categories. One is the peripheral milling, and other one is the face milling. So peripheral milling means, so this whatever you're seeing in this diagram, it's a peripheral milling. So maybe we can go for next slide to understand what is the peripheral milling. So this is the peripheral milling. If a peripheral milling means, so whatever the milling cutter is in a circular form, so periphery of the circle, so periphery of this circle, you have a cutting tools. So you see here, if you take this as the circle, so periphery, here one cutting edge. So here one cutting edge, here one cutting edge, and here one cutting edge. Periphery of the cutting tool having a cutting edges. So by that cutting edges, removing the material. So this is a machine surface, machine surface, and this is unmachined surface. So some layer of the material is removed. So this layer of the material is removed from here. So this layer of the material is removed by the at the periphery of the circle. That's why I used to call it as the peripheral milling. So this is one type of milling process. And second one is the face milling. So normally we have seen, when we have seen in our lathe when you're doing the lathe machine, so this end portion is called as the face of the, if you consider this as a cylinder, so in this cylinder, this is considering as a periphery, and this is considering as a base, right? So base are nothing but face. So if you're machining using this, if cutting edges are at this particular side of the cutting tool, then we used to call it as a face milling. You say this one. So here, so even though you're having a cutting edges on the periphery, but main machining, so main machining is happening because of the cutting edges which is there on the face of the cutting tool. That's why this process used to called as a face milling. So these are only the two difference. So if the cutting edges are the peripheral of the cutting tool, that machining is called as the peripheral milling cutter. If cutting edges are on the face of the cutting tool, then that kind of milling process or that kind of cutting process is called as a face milling. These are the two broad classification of milling process. So milling process are milling cutters. So milling cutters we can classify into peripheral milling as well as the face milling based upon the cutters of the this milling cutter. So is it clear? So this is one of the questions may come for the 2 marks or maybe 5 marks for you. So peripheral, broadly classified peripheral milling and face milling. So then we can see the peripheral milling. So this is a typical peripheral milling process, milling machine or maybe peripheral milling process. In that peripheral milling, so this is a three-dimensional view. So anybody having any doubt? Anybody have any question? Vizarat, you want to ask any question? Vizarat, you want to ask any question? Are you available online? Vizarat, are you able to hear me?
Yes, sir.
So we mute then.
If yes, sir, I am available.
Okay, then mute because disturbance is coming from your side.
Yes, sir.
Mute. Okay. If any question is there, any doubt is there, you can anybody can ask me anytime. You can unmute yourself and you can ask me the question. If no question is there, please mute. So this is the typical front view because normally I told you if this kind of question is coming in the exam for the 5 marks or maybe 10 marks, please draw this kind of diagram. So don't draw this. I'm not asking you to draw this kind of diagram. So maybe possible you can draw at least one view. So this view, otherwise this view. Any one view you can draw. If you want to draw 2 views, that will be better. But only thing when you're drawing anything in your exam, don't waste your time, right? So within the time, maybe you can draw your right. So this is a typical this kind of diagram. Maybe you can practice to draw in the exam. Don't practice this kind of diagram, right? So this in this, if you say peripheral milling, so you can see in your side view. So this is your front view, you can say. So this is your front view, right? And this is your side view. So if you take this is a side view, if you see in this side view, maybe I'll remove these lines. This may be confusing to you. So if you see, so this whatever the side view, so you see cutter. So what is the this dark line? You can see this nothing but cutting edges. So these cutting edges is peripheral to the cutter. That's why this is called is a peripheral cutting. So this is a peripheral milling process. So similarly here, if you see here in this, so if you see this, so this is a typical. If you take the front of side view, if you take the front view, so this side, so this you can see. So this is, so whatever the edges you can see, these are all cutting edges. So normally milling cutter is multi-point cutting tool. So last time, whatever we have seen in shaper, slaughter, and planer, whatever the cutting tool we are using, that is single point cutting tool. Similarly, lathe, whatever the cutting tool we are using in the lathe is a single point cutting tool. But whatever the cutting tool we are using in drilling, so used to call it as the drill bit. So drill bit is not a single point cutting tool, it's a multi-point cutting tool. Similarly, milling cutter also is a multi-point cutting tool, not a single point cutting tool. You see here, so how many cutting edges are there? So multiple cutting edges are there. Maybe you can see whatever the dark lines are there, or maybe whatever the dark projection lines are there here. So everything is a cutting edges. So in one cutting tool, you having a more number of cutting edges are there. That's why this tool is called as a multi-point cutting tool. This kind of questions may come in your objective exams. So similarly, in the GATE exams, also competitive exams, these kind of questions, simple questions, they may ask you. So normally in competitive exam, they may not ask you the derivations, they may not ask you the classifications, they may not ask you this kind of question. They will ask you the basic questions. So how basic things you understand. If you understand basic things, you can understand the complicated things also. So these kind of pay attention. That's why whatever we are telling, I'm telling to in the class. So each and every point is important. If possible, you can make note of these things. So these things will be useful for you in your exam, especially for the competitive exams. Your university exam definitely useful. In university exam, they will ask you derivation, they ask you the problems, all these things they will ask you. But in competitive exam, they're not asking the derivations. They're not asking you the explanation. They're asking you the only critical things. So multi-point cutting tool or single point cutting tool. So how many different types of cutting tools are there, and what is the difference between those cutting tools? Those kind of things only will ask in the competitive exams. Or maybe if you're going for any job for the interview, they'll ask this kind of questions. They may not ask you the derivation. But for the university exams, the derivation explanation is important. For your competitive exam or for your job interviews, this kind of conceptual questions also is important. So pay attention. That's why you read your textbook properly, thoroughly, attend the classes regularly. If you attend the classes, even in classes, you attempt you. So you need to be pay attention to the lecture. It's not like that simply you are attending and you're not paying attention. There is no use. So that's what you will give is only your login for the class, because sir is telling, because of attendance, just simply log in. There is no not serving the purpose. If you really want to serve the purpose, please attentive in the class. If any doubt, you can ask your faculty. If in this subject, you can ask me. In other subjects, the particular subject faculty, you can ask the doubt. So coming to the peripheral milling cutter. So peripheral milling, this is a typical peripheral milling cutter. Maybe you can see. So all cutting edges, maybe different size, different shapes of cutters are there. But all the cutters, what is the common thing is there on its periphery only having a cutting edges. So here, this is a typical slab milling, helical milling, coarse tooth mill cutter, right? And this is a slitting saw. So this is slitting because very thin in shape, like it's a your saw, hacksaw, power hacksaw, maybe you've seen. So similar to the hacksaw, only it is there. So it is circular disc kind of thing is there. This is called as a slitting saw. So interlocking mills, side mills, and staggered tooth mills. So if all milling cutters, you can see the cutting edges are in the periphery. So this is called a peripheral milling. So in peripheral milling, the axis of the cutter rotating is parallel to the workpiece surface to be machined. So whatever the axis, maybe you can see in previously also in whatever the is there. So axis of the rotation is parallel to the workpiece. So this is the surface of the workpiece. So this was surface of the workpiece and axis of the cutter is parallel. So always in peripheral milling, axis of the rotation and surface of the machining is parallel. So axis of the cutter rotation parallel to the workpiece surface to be machined in peripheral milling. In peripheral milling, again, we can classify the different kinds of milling. Slab milling. So cutter width, normally slab milling means cutter width is more than workpiece width. So cutter width is extended. Maybe in next slide, if you go, so you can see here, this is a typical slab milling. So in this slab milling, the same thing, whatever you've seen. So this is the workpiece and this is the cutter. So here slab milling means your cutter width is less than your is more. So cutter length is more than width of the workpiece. So what happened by one rotation? Once you move your workpiece from here to there, your complete surface will machine. So that is called as a slab milling. So in one movement, you can completely machine your surface. If you want to further depth, you want to increase, then maybe you can move once again. Otherwise, only if you want to remove the rough layer on the surface, only one movement is sufficient. Once you are moved workpiece from here to there, so complete your surface is completely clear. Your complete surface is completely machined. So this kind of milling process called as a slab milling. Slab milling. Then slot milling is nothing but cutter width is very less than the workpiece width. So slab milling means it's very slotting. So slotting is very small. Whatever you've seen the disc previously. So normally disc is using for slitting. So cutter width is less than the workpiece width. Create a slot. So making a kind of slots or a kind of grooves in the workpiece. So if the cutter is very thin, it can be used to cut the work into the parts or nothing but slitting. Slitting and slotting, two different. Slotting is nothing but you're making some kind of internal grooves, maybe keyholes or maybe some kind of grooves you're making. That is called as a slotting. Slitting means you're making two halves. So this is slot cutting. Slotting means it's your width of the cutter is less than width of the workpiece. Side milling. So side milling normally used to cutting the edges. So side edges. So cutter machine the sides of the workpiece. And similarly straddle milling. Straddle milling means it's cutting the two sides at a time. So similar to the side milling, but cutting takes on the both side of the work part simultaneously. If side milling is happening both simultaneously, both two sides of the workpiece is machined simultaneously, that used to called as the strad milling. Maybe you can see here, this is a typical strad milling. So in this is a typical workpiece. So both side of the workpiece is machined simultaneously. That is strad milling. Where is a side milling is, this is a side milling. So side milling means only side of the workpiece you are machining. So this layer of the material you are removing. So this is called as a side milling. So strad milling, side milling only one side. Strad milling is nothing but side milling in the two sides. And this is a start milling. You are making some kind of slots. And this is a form milling. One more important milling process is called as form milling. So form milling also we have studied in our lathe. So whatever the size of shape of the workpiece we want to make, so similar kind of the tool we need to use. So whatever the impression or whatever the shape of the tool is there, so that shape or nothing but that dimensions of the tool dimension is transferring of the workpiece is called as a forming and nothing but form milling. Because you see, so your cutter is this shape, so similar kind of shape of the workpiece you are making. So this is called as a form milling. Here, similarly here, if you take, so this is a different kind of cutter. So whatever the cutter shape is there, that is cutting. So actually, if you take this one, this is nothing but in the shape of a two gear teeth gap. So whatever the gear teeth is there, similar type of shape is there. If you cut this material, so whatever the teeth gap is there, the teeth gap is cutting here. So when you are removing the teeth gap, so whatever the remaining is there is nothing but it is a teeth. So this is a typical form milling process. Whatever the shape of the workpiece you required, the similar kind of the cutter we are using, and whatever the shape of the cutter, that cutter shape is transferring on the workpiece. This is called as a form milling. So in addition to these milling processes, so milling based upon the mechanism, again milling classified into two different categories. This is a milling mechanism or nothing but milling process. Depending upon the cutter, we have classified previously to surface peripheral milling as well as the surface milling. And depending upon the mechanism, we can classify milling into the two categories, that is up milling as well as the down milling, right? So these up milling and down milling, maybe we can see after the break. So any student having any question, please ask me. So peripheral milling and face milling is classification based upon its cutter, but based upon the working principle. So based upon the principle, we can classify milling process into two categories, that is up milling and down milling. So maybe you can see in this picture. So this is a typical milling process. So if you take in this, so this is a milling cutter. So milling cutter rotating in this direction, right? And workpiece is feeding. So always remember in milling process, so cutter is rotating about its axis in a circular motion, and as well, at the same time workpiece also is moving forward or nothing but if you take, so one direction it is sliding. It is linear motion is there in the workpiece and rotational motion is there in the cutting tool. So if these two tools are on the opposite direction, what are the direction of motion? At this particular point, if you say, even though it's a circular motion, if you want to take a direction velocity vector, so velocity vector is something about showing in this direction, right? So this kind of process, you see, workpiece is rotating in this direction and tool is rotating in this direction. So this is called as a up milling process. So up milling, machining is machining. This is nothing but whatever the hatch portion is there. So this hatched portion is the chip. So chip are nothing but material is removed when the cutting tool is moving upward direction. So cutting tool is coming from here, there is no machining, right? It's downward direction, right? From up, if you take this teeth, so this teeth is moving from up direction to lower. This is nothing but it is the downward direction it is moving. At the downward direction, there is no cutting. So cutting is happening when this tip of the tooth is moving from lowest portion to when it is raising from its position. It's nothing but going for up. That's why this is used to call as up milling. The material removal or nothing but cutting of the material is happening when tool or nothing but your cutting edge is moving upward direction. That's why this is used to called as up milling. So also called as a conventional milling. Actually, this is the conventional milling process. So this both, so direction of rotation or nothing but cutting tool direction as well as your workpiece direction, both are opposite. That's why this kind of this is a conventional milling process. So up milling or conventional milling, same thing. So wheel rotates opposite to the opposite of the feed. So this is considering as a feed motion, and this is considering as a cutting motion. So both are in opposite direction. The chip formed by each cutter tooth start out very thin. So you see in this picture, so initial of the chip is thinner. So as material is cutting, so your chip is become thicker. So at the end it's become thick. So thin to thick chips are formed. So chip formed, each cutter tooth starts very thin and increasing its thickness. So this kind of chips are forming in upmilling. Whereas in a previous milling, previous machining process, our chips, if you take in lathe, so we assume that thickness of the chip is uniform from starting to end. But in milling process, starting to end, chip is not uniform, because here chip is not like very long chips like in lathe. So here chips mostly, most of the chips are only up to whatever the thickness of the workpiece. So this thickness of the workpiece is varies. The thickness of the chip is varies. So in upmilling, it is initially it is small thickness. So as at the end of the cutting, so it's become very thick. Thick. So thin to thick, it is changing. And similarly, the length of the chip is relatively longer. So in this, so upmilling, compare with the downmilling, next part of the milling we're seeing. So normally length of the chip is a little longer. It's not very long, like in lathe. It's not like continuous chips. So whatever the length is there, so it is little longer. So tool life relatively shorter. Why? Because you having more force is required here. So because both in opposite direction, right? So this is moving this direction and this is moving this direction. So that's why, so more force is involving. That's why you need to have the life of the tool is decreasing, because more force is applying, more stress is causing. Because of that, wear and tear is comparatively it is more. So means tool life is decreasing. So need more clamping force, because both opposite directional force is acting. So that's why it used to have the clamping force, as well as machining is happening when upside it is going. So if proper clamping, if you're not provided, proper clamping on the table, then what happened when it is moving, it can lift the workpiece. To avoid this, you need to have very strong clamping force is required. Normally for upmilling or conventional milling, so very good strong force is required to hold the workpiece. So these are the basic things for upmilling. So everybody note down this. Otherwise, maybe at least you can take a screenshot. So then I'll go for next process, that is down milling process. So this is a typical down milling. So same process, same workpiece is rotating on the same direction, but moving on the same direction. But only thing here, so cutter direction of rotation is changed. So previously it was this direction. Now cutter is rotating in this direction. So workpiece is moving on the same direction. The cutter rotation is changed now. So if cutter is rotating in this direction, what happened here? If you take the linear motion at this particular point, so this is in this direction, right? So in this direction, and workpiece also in this direction. So in this direction of cutter rotation as well as the movement of the workpiece in the same direction. So this kind of machining is called as the down milling. So down milling, why it is calling? So because when the cutter is moving from this whatever the cutting chip is there, the tip, so when it is down, so movement when it is going down, at that time removing the material. That's why this process is called as the down milling process. So also called as the climb milling. Down milling are nothing but climb milling. So previously up milling, conventional milling, down milling is nothing but your climb milling. The wheel rotates parallel to the feed. So as I told you, so this direction of rotation of the wheel as well as the direction of the workpiece movement, so both are in the same. So both are parallel and same direction. The chip formed by each cutter both starts out thicker, so quite opposite to previously. So it is starts out thicker, and it is as goes on, it is the thickness of the chip is decreasing, because you see when the workpiece is there, so workpiece maybe it is when it's touching this, it is removing here maybe a little thicker. So as it goes on, your thickness of the material, thickness of the chip is reducing. It's quite opposite to previously in upmilling. The length of the chip is relatively shorter. So compare with previous, it is relatively little bit shorter. So length of the chip is very small. So tool life is relatively longer. So why? Because the both are moving in the same direction. The clamping force normally is not a heavy clamping force is required. Maybe small sufficient to holding in this particular position, that clamping force is sufficient. So that's why force is involving is less. So because of less force involved, so less stresses are generating into the cutting tool. That's why tool life is comparatively is longer than upmilling machine. So need less clamping force. So as I told you, because what happened when the material removal is happening when it is going down. So there is no lifting like previous case. There is no lifting is happened because already this is mounted on a surface, right? So that is stable, or maybe work holding device and wise, or somewhere it is holded. So because it's not required, it is not required any heavy holding force is not required, because it's not lifting like previous case. just is cutting and then it is going idle. So this whatever the cutting tool is going, there is no cutting happening in this portion. So this is the typical differences between up milling and down milling. So this is maybe one questions may come from this too. So maybe people may ask you to explain about up milling or down milling, or explain about up milling, or maybe difference between up milling and down milling. So definitely 2 marks or 5 marks question may come from this these things. So maybe next we can go for next slide. So then coming to be face milling, right? So we discussed about up to now we discussed about peripheral milling. Now coming to be face milling. So in face milling, what happened? The cutting tools are at about the face. So previously we having a arbor. So arbor having a horizontal axis. On that horizontal axis, we used to have the cutting tool, or nothing but milling cutter is mounted. Now in this face milling, normally we used to have a vertical cutter. So cutter axis has to be vertical, not perpendicular, not parallel. So this is a typical. This is similar to your drilling machine. So if you take, say, see here the side view of this one, if you see from this, so this is typically your drilling machine, same, right? So in drilling machine also you having the same kind of drilling head, drill bits are mounted here, same kind of thing is there. So instead of drill bit, so we having a milling cutter. So drill bit normally used to make the hole, but this is not making the hole. So main purpose of milling machine is not making the hole. It has to machine the surface of the workpiece. So maybe the small workpiece mounted on the vise, and this is the cutting tool. So using cutting tool edges at the end, cutting edges at the end of the face of the cutting tool. So that's why this process is called as a face milling. This is a typical face milling. So in this, if you take the main parts, so this is a vertical column. So machining head, so cutting tool, machine wise, almost the main important parts of face milling or your peripheral milling almost same. Only thing your direction of axis are only changing. Direction of cutting axis only changes. So machine wise or maybe work holding device, and this is the table, cross travel and hand wheel to change, to raise this as well as to move, and as well as this. Normally this whatever the work table used to called as a knee in milling machines normally. And this is the vertical travel. We can adjust the table like similar to our previous whatever the machines we're seeing. So what are the different types of face milling? So normally face milling, so generated surface is at right angle to the cutting axis. It is the combined result of action of the portion of the teeth located on the tooth periphery and the face of the cutter. So in this, in face milling, normally in previous, in peripheral milling, we've seen the surface of the workpiece as well as the axis of cutter rotation are parallel. But here it is perpendicular. So direction of rotation of the workpiece is perpendicular to the surface. So if you take, this is the surface, right? So this is the surface of the workpiece, and your axis of the rotation of the cutter is this vertical plane. So these both are perpendicular to each other. So this maybe you can see. Yeah. So if you see here, so this is your face, right? To face, it is the axis of the rotation is exactly perpendicular. So previously it was parallel, but now it is a perpendicular. And basically cutting happened. So cutting mostly is happened by the edges. But in some cases, so whatever the cutting, whatever the edges are there, so at the periphery that also doing, but that cutting is very small cutting is happening. So most of the cutting is happen at the whatever the cutting edges on the surface are nothing but on the face of the milling are nothing but on the end of the cutter. So that cutting edges only remove the material. So most of the cutting is done by the periphery portion of the teeth, with the face portion provided some finishing action. So in this, if you see, so in this, whatever the things are there, it is the end portion only is doing. I think this is, so this is not most very small correction, small machining is happened by the peripheral, and major portion of the machining is happened by the surface, which is there on the end of the cutting tool. So this is doing only finishing. The peripheral tool is only doing finishing process here. So conventional face milling, so diameter of the tool is larger than the workpiece. The conventional face milling process, if you say, like previously we've seen slab milling, similar to the slab milling, here in the conventional face milling process, what happened, the width or nothing but diameter of the cutter is more than the width of the workpiece, so that in single pass you can finish the machining. So partial face milling, in partial face milling, the cutter overhangs from the side of the work part. Maybe in the next slide, maybe you can see. So this is the typical your overhanging. So if you take here, so this is the conventional. So this is a conventional face milling. So here the thickness of the whatever the cutter length is more than your workpiece length. If cutter length is less, so maybe you can see here. So this end milling, if cutter length is less, so then it is called as a partial face milling. Means whatever the cutter is there, so maybe this is your workpiece, right? And cutter thickness, nothing but diameter of the cutter is smaller. So then in single operation, you cannot complete the work, your machining of the surface. Then what you need to do? We need to have multiple passes are required. So once from here to end, from starting point to ending point, once you can move, then again you need to lateral movement. The lateral feed has to give to the workpiece. Workpiece has to move this direction, and your cutter has to come at this particular position. Again, it has to move like this. Your complete machining is happened, and more number of the travel process, right? So it has to, for example, this is the size. 3 to 4 passes are required to complete one surface machining. So that's why this is called as a partial face milling. So full face is not covering by this cutter. So only partial face only covering. That's why you used to call it the partial face milling. The cutter overhangs from the one side of the workpiece. So this may be overhanging sometimes. And end milling. So end milling cutter normally, so only for ends. If you're machining only ends, then it is called as end milling cutter. So cutter diameter is very less than the work part width. So then profile milling. So profile milling is nothing but in different kind of profiles if you want to cut. So uneven surfaces, some curved surfaces are there. So that kind of process also can be possible on face milling. So this kind of process is called as a profile milling. So maybe this kind of profile has to cut, maybe some kind of circular profile, or maybe some kind of elliptical surfaces, some kind of parabolic surfaces has to machine. So this is called as a peripheral profile milling. Nothing but whatever the periphery is there. So in peripheral, so whatever the shape is required, whatever the dimensions are required, so the dimension you're cutting the material. So similarly, packet milling. So packet milling is nothing but groove milling. So making some kind of packets into the workpiece. So similar to the end milling, so but the shape created is a shallow packets in a flat surface. Maybe this kind of things. So packet milling. So in groove milling, normally you used to use the same size. What are the size of the cutter? Same size of the cutter you're making. But here in packet milling, so bigger size you can remove the material. So means whatever the end milling cutter, whatever is there, face milling cutter. So this face milling cutter is doing like a drilling process. In drilling process, what you used to do? You used to remove the material in circular shape, but not in the circle, because you having primary cutting edges on the outside. So you need to make the hole in this, and then we can drive the cutting tool, whatever the dimension, whatever the shape and whatever the dimension you want to keep, and you need to keep it. Your cutting tool is following this direction. When you're following this, so finally you're going to get this kind of packet into the workpiece. This kind of machining is called as a packet machining or packet milling process. So maybe you see in this, so maybe you're having a typical rectangular blocks or your machine. So this is one typical 2 rectangular grooves or big rectangular holes or packets are made in this. So this kind of process is called as a packet milling. And this is the surface contour. So in surface contour, a ball nose cutter is fed back forth. So it is moving front and back, and we are making a contour kind of things we are making on the surface of the material. So this kind of process, milling process, is called as a surface contouring. In surface, you're making some kind of different kind of contours you're making. So profile milling. So profile milling means whatever the profile is there, so that kind of shapes or that kind of profiles you can make. Profile milling, end milling. So end milling normally used to use the ends of the workpiece to be machined. So here, if you say, so this is the facing, right? Partial facing. So partial facing, and this end milling. So end milling we are doing with whatever the workpiece is smaller. Then profiling. So what are the different kinds of profiles you're cutting on the workpiece? So profiling, packeting. So packeting is nothing but you're making some kind of internal groove, some kind of typical shape of the internal surfaces you're making. And surface contouring. So different kind of contours on the surface is called as the surface contouring. So these are the basic end milling processes are there. So surface milling as well as the end milling, peripheral milling as well as the end milling, both are very popularly using in milling process. So a few more examples of the face milling is the shoulder milling. So if it is machining at the yes, any question? Any questions? Any questions, please ask me. Otherwise, you see in this, so different things are shown in this. So in that, whatever the ends you are making, so ends is making is considering as a shoulder milling. And similarly, you're making a grooves is called as a groove milling. And ramping. So ramping means you're making a groove. So similar to this, but here, so whatever the surface is there, surface from here to end is same level of the surface you're making. But in ramping, so the some inclined surface you're making. So means as the workpiece goes on, so it is vertically also you are giving. So vertically it is adjusting its length. So here maybe if you take from this, so here whatever the height is there, so it is less, and as it goes on, so this height at the thickness of the material in this particular position is changes. So maybe you can see here. So you are making some kind of inclined surfaces are making. Internal inclined surfaces you are making is called as a ramping. Not only in internal, even you can make some external surface also you can make. Maybe some kind of inclined surface you're making here. Inclined planes you're making. So this is also called as a ramping. And packet milling, so already we have seen. Even we can do the drilling also on this. So if it is not very long deep holes, smaller depth of the holes can possible to make. So even drilling also can be possible to make in milling machine. And similarly, helical milling. So helical milling is nothing but you're removing the material when it is rotating in the helical shape. Normally in this, whatever the cutter, if you say, so here you used to have a carbide tips are connected to the cutting tool. So in this, each cutting edge is having a typical cutting edges are attached to here. So normally for very hard materials or maybe very tough material which is very difficult to machine, so for that we used to use this kind of tools. So these are the few work holding devices. So these work holding devices are mounting on the work table on the milling machine. So then we can use it. So maybe in this, maybe you can see when I discussed about work holding devices in the previous chapters also. So these are the angle plates. So these angle plates are used to mount on the table. So on work table by using bolting in this. And in this you having a slot. So these slots, so using in these slots, maybe by using stick clamps and other, you're holding the workpiece. So behind this, you're holding the workpiece in this angle plate. Similarly, V blocks. So V blocks mounted on the table, work table. And if you want to have normally for circular objects, we used to use this kind of V blocks. And then popular the working tools, whatever is there. So maybe most popularly whatever we are using. So on smaller workpieces is. So these are the few work holding devices which is using for on the milling process. This is normally these work holding devices are using for small to medium workpieces. So these are the typical milling cutters. So maybe in milling cutter, maybe you having a peripheral milling cutter. So this is a helical milling cutter. This is end milling cutters. Different kind of milling cutters are there. So end milling cutter as well as a peripheral milling cutter, different sizes, different shapes. So these are the few typical milling. This is used to called as the slotting, right? Very thin disc milling cutter. So very small thickness. So that's why I used to call this disc milling cutter. So this is using for surface machining as well as the slitting of the workpiece also can be possible using this cutter. So then coming to milling cutters. So different kind of milling cutters. The tool used in the milling cutter normally in the milling is called as a milling cutter. So the cutting edges called teeth. So whatever the cutting edges are there, so that may be on the periphery or maybe on the surface. So that is called as the teeth. The types of milling cutters are related to the milling operation. So depending on the milling cutters, milling operations can be classified as the plain milling cutter as well as the side milling cutters, whatever just now you see. Any questions? Any questions? Ahmad bin Kursain. Any question?
No, sir.
So why you are then switch on your mic? Mute your mic.
Yes, sir.
So based on the milling cutter, again the different things are there. Plain milling cutter as well as the side milling cutter. So plain milling cutter normally used in the peripheral milling operation. So cylindrical disc shape, it is plain milling cutter. Have several straight or helical teeth on the periphery of the cutter and used to mill flat surfaces. Normally plain milling cutter used for the flat surfaces. Similarly for the side milling cutter, so similar to the plain milling cutter. So teeth extend radially, so partway across the one or both end of the cylindrical toward the end. So side milling cutter is similar to your face milling. So relatively narrow. So normally whatever the dimensions are there, its dimensions of a side milling cutter is smaller than plain milling cutter. So coming to the milling cutter, if you take this is a typical helical milling cutter. So whatever the milling cutting edges are there, so it's not parallel to the axis of the rotation. It's making some kind of inclination. So this used to called as a helical cutter. Whereas this is the plain milling cutter. So axis of the rotation and your cutting edge, both are perpendicular, parallel to each other. So this kind of things used to call as the plane milling cutter. If you take the nomenclature of the cutting tool, or nothing but your milling cutter, so this is a typical milling cutter. So in this, if you say, so this is a typical milling cutter. So in this, these are the cutting edges. So these cutting edges similar to your single point cutting tool, whatever we have discussed in the first unit. Same thing. So in that, maybe you having some clearance angle, some rake angle. So everything is there. So whatever the portion is there, this is a typical. If you take, see this one. So in this, whatever is there, this is one tool, cutting tool. So one cutting edge. So like this, you having a multiple cutting edges are there in each cutter. So in this, whatever this portion is there, which is not directly coming in contact with the workpiece, is called as a land, and this portion is called as the flank, face. So face, this is the face and this is the flank, because once material is removed, so your material is coming on this surface. That's why this used to called as a flank, and this used to called as a land. And this, whatever the depth is there, so this length of this, how much depth of this edge, that is called as the depth of cut, nothing but depth of tooth. So this much thickness of material can be removed in one pass. So this is called as a depth. So pitch of the teeth. So pitch of the teeth is calling at which distance. So this is one cutting edge and this one cutting edge. So radial distance between the successive cutting edges is called as a pitch. So pitch is nothing but it is the circumference, diameter of the circumference of the circle divided by number of edges. How many edges, cutting edges are there on the surface? That will give you the pitch of the teeth. So this pitch is similar to the pitch you studied in your gears. So in gears and threading in your DME and as well as in mechanics of solids, you studied about the pitch. So this is all the same thing. So pitch is nothing but distance between the corresponding cutting teeth. So nothing but cutting edges. So these are the typical things, and this whatever the inclination, because this is the face. So whatever the face angle is there, so whatever things are there, so vertical to how much this is backside, so this is giving as a rake angle. So like single point cutting tool, if you want to refer, if you want to go back to the single point cutting tool, one of the important parameter there is the rake angle. So here also rake angle is there. So this whatever the your cutting edge, actually this cutting edge, so this is vertical. So this with vertical, your cutting edge is little bit inclined is there. So this angle, whatever the inclination is there, that is called as a rake angle. And there is a keyholes are there in that. So the keyholes is providing, because this whatever your cutting tool is there. So milling cutter. So this milling cutter normally we placed on the armor, right? So on that armor, if you simply you keeping, so there is a relative motion may happen between the armor, so which is there in this, and your cutter. To avoid that, we are providing some kind of keyhole, and in that armor, your arbor used to have this kind of projections are there in that arbor. So that projection is coming and sitting in this keyhole, so that whenever the arbor is rotating, so along with the arbor, without any slipping, your cutter also is rotating. And here, if you take in the side view, this is the front view. If you take side view, if it is a plain straight cutter, so this your cutting tool is in this parallel to your axis. But here, your cutting tool, if it is not in the axis, then maybe you are getting some kind of angle. So this angle is called as a helix angle. So helix angle, if you take in these two, so plain helical cutter and as well as plain cutter. In plain cutter, this helix angle is 0, because your cutter cutting and your axis is on the same direction. So angle between these two may not come anything. So this angle between these is 0. If angle between these, the helix angle of a milling cutter is 0, then we can call it as it's a plain milling cutter, or nothing but straight milling cutter. If it is having any inclination, then we can call it as a helical milling cutter, or nothing but helical cutter. So this is the typical nomenclature. If somebody will ask you in the exam, explain the nomenclature or about the cutting tool, so then maybe you can show this diagram you need to draw. So whatever the diagram is shown to you, so this diagram you can show, and all these parameters maybe you can show in it. So these things, maybe this definitely in this also maybe possibilities are there. So may come definitely 2 marks or maybe 5 marks. Coming to the next one. So this is a typical peripheral milling. So not only this kind of thing, even different kind of shapes, different kinds of things will be there in the peripheral milling. So already this peripheral milling cutter maybe previously I have shown. So similar kind of things are here. The same thing. If you take this, the same thing is here. So this kind of thing. So this kind of, if you take the side view or nothing but your cross sectional view, if you say, so it's look like this. The cutter is look like this. The farm milling cutter, so another peripheral milling cutter, farm milling cutter, I think previously we discussed. So another peripheral milling cutter, so farm milling cutter also is a peripheral milling cutter, because we used to transfer whatever the shape in the cutter, the same shape we are transferring to the onto the workpiece. So that's why this is considering as a peripheral, another peripheral milling cutter. So teeth ground to special shape to produce a surface having a desired transfer contour, convex, concave, whatever the shape is required, the same kind of shape is, we made the tool, the same kind of shape we transferring on the workpiece. There is an end milling cutter using for end milling. So look like a drill bit. So bit it's cut with the peripheral teeth instead of its end. So have a multiple tools. In end milling cutter is even for drilling. So in end mills, end cutter as well as then the peripheral, what are the cutting edges are there, both involving the cutting action. So in this, having a multiple tubes, normally every milling cutter used to have a multiple tubes. So used in milling slots. So end milling cutter also used for the milling slots, profiling, facing narrow surfaces. So all these different kind of processes, whatever you've seen, profile milling, contour milling. So all these things normally we using end milling cutter. So farm milling, typical farm milling cutter this is. So whatever the shapes are there, you see different shapes are there, each having different shape. And whatever you're seeing, these are the cutting edges. So whatever the shape of this cutter is there, shape of the cutter is transferring on the workpiece by removing the material in this path. Similarly, this is one more periphery. So this is a convex. This is contour, convex, and this is the gear tooth cutter. So in this, whatever the tooth is, this cutting profile is there, it's similar to the gear teeth. So single cutter, single angle cutter, so single angle, and this is a double angle. So this is one angle, and similarly other side also you have to have one more angle, and this is the concave. So this is the convex, and this is the concave. So you know what is the concave and convex. So convex and as well as the concave also can possible to cut using this milling cutter. So whatever the different shapes is required on the surface, all these kind of different shapes can be possible to make using this kind of milling cutters. So this is typical end milling cutters. So end milling cutter normally used to have the cutting edges at the end of the milling cutter. The face milling cutter have teeth in the periphery and both sides made of high carbon steel. But the one more important thing is T-slot cutter. So in T-slot cutter having teeth on periphery and as well as on the both sides. So it is on there on the periphery as well as the both sides. So all these all these sides, wherever the tooths are there, so those tools are cutting the workpiece. That kind of tools is called as a slot milling cutter. And T milling. This is a typical T milling cutter. So in this, you see there is edges there. So if you want to move the cutter, so it is removing the material. So maybe I can show. This is the typical peripheral milling, T-slot milling cutter. Have teeth on periphery and tooth sides, used for milling of wide grooves of T-slots. Whatever the T-slots maybe you can see on your work table. So all these T-slots normally used to make using milling machine. So in order to use them, a vertical groove, so must first be made. Normally, if you're using for normally groove cutting, so groove milling. So what you used to do if you want to make a typical, maybe I can. If you want to make, this is a typical T grooves we need to make in the table, for example, right? So this is a table, right? So in this table, if you want to make a T groove, this kind of groove, if you want to make, what we need to do? First, we need to make this kind of groove first, right? First, you make this kind of groove, then you can put one single point cutting tool and removing the remaining material from here, right? But if you're using this T hole, so your T hole is similar to your this groove. So T hole, in this T hole, for example, this is similar to this one. In this at periphery, you used to have the cutting edges. So at periphery, you have cutting edges, as well as on top, you have cutting edges. So you have cutting edges in this direction, as well as your cutting edges in this direction. Also cutting edges are there. So when you are keeping this at this particular position and moving perpendicular to this screen, so what happened? So this, because this periphery, this is circular shape. So all the cutting tools, cutting edges are there. So as it's moving and touching with the workpiece, what happened? The same, this kind of slot, it is moving as the workpiece. For example, if you take the side view of this, if you want to take side view of this, maybe I can draw a side view here, right? So this, your cutting tool is moving from this direction. As it's going in this direction, perpendicular to this, if it is going, what happened? So whatever the shape of the tool is there, the same shape of the tool, groove it is making, right? So this is a simple process. If you're using T-slot with single movement from one direction to other direction, when the tool is rotates, you will make this T-slots. So it's T cutter is very simple. If you're not having T-slot cutter, if you want to make a single point cutting tool or maybe with a cutter, End milling cutter, what has to do? First you need to make this, and then you need to removing this material. It's very long process it will be. So in order to use them, a vertical groove must be first made with a starter if you are using with this. T-slot cutter must be fed carefully because it cuts in 5 surfaces. So it cuts 5. This is 1. So you see this is 1 surface. This is 2. So this is 3. This surface is 3. This is 4. So this is 5. Like this, 5 surfaces used to have cutting edges. So 5 surfaces it used to machine. That's why this the very careful unit when you are machining the T-slots, you need to be very careful. So these are the typical T-slots cutter, or face milling cutters also. The face milling shell, the rectangular cutouts area on the face side. So this is a typical a model tool. So this is a teeth, right? This is a cutting edge, and this is your face, and this is the land. So like this, you having a multiple cutting edges are there in a circular cutting tool. So this is a typical T-slot milling. So T-slot milling is this. So in this, if you say, so you're having cutting edges. So here you having cutting edge. This side you have cutting edge, and this back side also you have to cutting edges. Like this, all 5 sides you need to have cutting edges. Narrow slotting. So wood cutter, wood roof cutter. So deep slot cutting. So if you want to make more deep, maybe you can increase. Long reach T-slot cutter, and as well as this is the typical T-slot cutter. So this is the typical T-slot cutters are there. So again, whatever we discussed, maybe again I'm just reminding. So now our time is coming to end. So just I want to remind this. So whatever you have seen in this is slab milling. So whatever the slab milling, maybe you can see. So this is a peripheral, one of the peripheral milling process, slab milling. So cutter length is more than width of the workpiece. So with single pass it's complete. And face milling. So end of the faces used to use to milling the process, and end face milling and also end milling. So end milling normally used to the cutters at the end as well as at the periphery. It's to use to make some kind of grooves, some kind of packets in the workpiece. And straddle milling. So straddle milling is nothing but end milling, but here end milling is doing both direction simultaneously together. Straddle milling and then form milling. So these are the basic milling processes or milling cutters are there in milling. So milling machines, maybe we can see in the next class. So today we discuss about milling mechanisms, milling process, as well as the milling cutters. So anybody having any questions in today's class, please ask me. So milling machines, types of milling machines, you can see in the next class. Yeah.
In periphery milling, that is a tool